In this problem we have f is the function given by f of x is e to the negative x squared. We want to write the first four non-zero terms and the general term of the Taylor series for f about x equals 0. Alright, so we're going to start with what we know. E to the x is 1 plus x squared over 2 factorial plus x to the third over 3 factorial, etc. And then we're going to go on from that to e to the negative x squared is simply going to substitute a negative x squared wherever we see x. So 1 plus negative x squared plus negative x squared, negative x squared to the second over 2 factorial plus negative x squared to the third over 3 factorial, and so that should do it for the first 4 terms. Now what that means is that any odd terms are going to come out to be negative. So 1 minus x squared and then plus x to the fourth over 2 factorial, then minus x to the sixth over 3 factorial, and that should do it. Now we're ready to find the general term here. So let's see what happens. We'll call this the 0, 1, 2, 3 term. Well, at least we can see that our denominators, those factorials, are just n. So we'll have n factorial in the denominator. And then we are going to have alternating terms. And since they start out positive, that will be negative 1 to the nth power. Now, following this, it seems that the x's are just going to be to the 2n. So we have 0, 2, 4, 6 for terms 0, 1, 2, 3. Alright, so I think we have satisfied the requirements for part A. Now, the second thing it says is to use the answer in part A to find the limit of 1 minus x squared minus f of x over x to the fourth power. Alright, so how are we going to do this? What we have right now is f of x. And we want to take 1 minus x squared and subtract f of x from that. And so that might look something like this. We're starting with 1 minus x squared and we want to subtract our function from that. Well, so what's going to happen here, we're just going to do a term-by-term subtraction. 1 minus 1, that's 0. Negative x squared minus negative x squared plus x squared is going to be 0 also. Then all the other terms are going to be opposite sign. So we're going to get 0 minus x to the fourth. That'll give us negative x to the fourth over 2 factorial. Then 0 minus negative will give us positive x to the sixth over 3 factorial. And if we wanted another term, we would have x to the eighth over 4 factorial, etc. I'll do one more. X to the 10th over 5 factorial. So it's going to keep going like that. So that is 1 minus x squared minus f of x. Now we want to divide all that by x to the fourth. And so 1, running out of colors here, 1 minus x squared minus f of x over x to the fourth. Now we just want to divide each of these terms by x to the fourth, and so we'll see we end up with negative 1 over 2 factorial, then plus x squared over 3 factorial, then minus x to the 4th over 4 factorial plus x to the 6th over 5 factorial, etc. Now, what we want even more than that is the limit as x approaches 0 of 1 minus x squared minus f of x over x to the 4th. And all we want to really do there is let all the x's go down to 0. And as all the x's go down to 0, we're going to be left with negative 1 over 2 factorial, which is simply negative 1/2. So I guess the moral of this story is that you can do all these transformations with the Taylor series that we create. We can subtract them from polynomials and do term-by-term addition, subtraction, etc., and division, as we saw there at the end. And the limit as x equals 0 is basically just setting all of the x's to 0, and what's left is the negative 1/2. So that'll do it for parts A and B of this problem.